Hello everyone, this side Manisha Mishra, Assistant Professor in Mathematics, Applied Science Department, Etce and Institute of Technology and Management, Gurgaon. This college is affiliated to Maths Danan University, Rohtak. So today I will discuss the topic of Charpit method to solve the non-linear partial differential equation. Right. So this is the strongest method to solve the all non-linear partial differential equation. In our previous session, I told you Lagrange linear partial differential equation of first order. So I will discuss two or more three topics related to non-linear partial differential equation solution, and I will also discuss the topic Charpit method. So this method is asked can become at least 7.5 marks or 15 marks maximum in your final semester exam. So prepare this topic because this is very important topic, right? So there is another method here, type 2. So equation of the type 1 I told you in our previous session, and here I will discuss type 2, type 3, type 4 like also, right? So equation of the type z is equal to px plus qy plus fpq. So its solution is z is equal to ax plus by plus fab. So you will remember direct solution of this equation. If you have the equation of this type, then you can write the direct solution that put p is equal to a, q is equal to b, so then your solution will be z is equal to x plus by plus f of ab, right? Now there is an example here. So solve z is equal to px plus qy plus p square plus q square. So you can see here that this equation is looking like this one. That means z is equal to px plus qy plus f of pq here, right? So you can put directly p is equal to a here, q is equal to b. Then your solution is z is equal to ax plus by plus a square plus b square, right? There is another example here. Solve z is equal to px plus qy plus square root of py. So this equation is also in the form of f of z is equal to px plus qy plus f of pq, right? So the solution will be, you can put z p is equal to a and q is equal to b here, right? So its solution is z is equal to ax plus by plus 2 root. Now here there is a type 3 is here, so you can see that equation of the type f of zpq is equal to 0 here, right? So it means equation not containing x and y. So what will you do? You will consider that z be a function of u, so where u is equal to x plus ay. So you can find it from here del u by del x. So you del u by del x, that means when you do differentiate u partially with respect to x, so that will be your 1. Del u upon del y, that will be your a, right? Then you will find next p is equal to del z upon del x. So your del z upon del x will be del z upon del u into del u by del x is equal to del z upon del u, because del u by del x is your 1, right? Now p is equal to, okay, okay, 1 minute. What is happening here? Right. So you can see here that type 3, so you will put the value of p and q in the equation, right? So q, you are getting q is equal to del z upon del y. So you can write del z upon del y as del z upon del u into del u upon del y, right? So del z upon del u into a, that means del u by del a, del u upon del y is equal to a. You have already find it, right? Now On putting the value of P and Q in the given equation, f of ZPQ is equal to 0, then it becomes like this one. Now, solve P of 1 plus Q is equal to QZ. So there is an example here, though, so we will better understand from the example. So solve P of 1 plus Q is equal to QZ. So let U is equal to X plus AY. Now, del U by del X is equal to 1, del U upon del Y is equal to A, we know that, and P is equal to this one, and Q is equal to this one, right? So put P and Q in equation 1, so dz upon du, 1 plus a dz upon du is equal to a into dz upon du into z. So dz upon dz here, in the left hand side, right hand side, both will be cancelled out, and you have 1 plus a dz upon du is equal to az. You can see here. Now, a into dz upon du, you can write az minus 1. So dz upon du is equal to az minus 1 upon a. So just separate z terms one side and constant terms another side. So you can write it du is equal to a dz upon az minus 1. Now integrating on both sides, so you will get your final answer. U is equal to log az minus 1 plus log c. So log m plus log n, you can write this one. So this is your final answer. Now equation of the type f1 xp is equal to f2 xq. So you can see here, this is your fourth method. You can see here that this function is containing only x and p terms. This function is containing only y and q terms, right? So let f1 xp is equal to f2 yq is equal to a. That means you are considering these function into is equal to a another constant, right? So f1 xp is equal to a. Then what will you do? Your next step is f1 xp is equal to a. That means you will consider left hand side is equal to that constant, and from here you will find the value of p in terms of a and x, and f2 yq is equal to a, another step. So you will find the value of q from here. So when you will have your p and q, then what will be your next step? You will put the value of p and q in the solution. Dz is equal to p dx plus q dy, right? Now dz is equal to, if you having p in terms of x, then write here q in terms of y, so right here, then integrating on both sides, then that will be your required solution. So we will better understand by this, by the example. So example is solve p minus x square is equal to q plus y square. So you can see here that p is having a function of x, q is having a function of y here. So f1 xp is equal to f2 yq is equal to a. This is of the type of this one. So p minus x square is equal to a, q plus y square is equal to a also. That means we are taking a left hand side is equal to a and right hand side is equal to a. Now another step, I told you that we will find the value of p and q from here. So p is equal to, we are getting p is equal to a plus x square, and q is equal to a minus y square, right? And next step will be put the value of p and q in dz is equal to p dx plus q dy. So when you will put the value of p and q here, then you can see that, okay, now you can see that the dz is equal to, why it is moving? Okay, this is happening again and again. So guys, sorry for this, right? Okay, so you can see here that p is equal to a plus x square, q is equal to a minus y square. So dz is equal to p dx plus q dy. So when you will put the value of p here, so a plus x square dx plus a minus y square dy, a dx plus x square dx, a dy minus y square dy. Then on integrating both sides, so integration dz is equal to this one. Just on integrating both sides, then you will get your final answer, right? There is an another example here. So, right. Okay. Solve p square plus q square is equal to z square x plus y. So this equation, that means p square plus q square is equal to z square x plus y. So you can see here that there is x and y also here, and there is another variable z is here. So you cannot convert this equation as f1px and f2qy. So what will you do? P square divided by z square, q square divided by z square is equal to x plus y. So you can write p square upon z square as p upon z whole square. Q upon z whole square is equal to x plus y. Now I told you in our previous session, I told you about that p is equal to del z upon del x, q is equal to del z upon del y, and you can write this term as del z upon z upon del x. Del z upon z upon del y whole square is equal to x plus y. Now you can consider del z upon del z upon z as a new variable, capital del z. So log z is equal to capital Z. Now this will be capital del z upon del x whole square plus capital del z upon del y whole square. You are considering that del z upon del s, small del z upon z is equal to capital Z. ना कि x and y आपके change हो रहे हैं, right? So x and y will be same as it is. Now this will be is equal to x plus y. That then you can write this term as p square, capital P square, this term as capital Q square is equal to x plus y. Now we can see here that our equation is in the form of f1px is equal to f2qy. So is equal to, now we can apply our rule. So this is equal to capital small a constant, then you can find p from here, q from here. So dz is equal to, you can write p dx plus q dy. This write the value of p and q here, and you will get dz is equal to square root of a plus x plus y minus a. Now on integrating both sides, so z is equal to square root of a plus x dx plus square root of y minus a dy plus c. Then after integration, you can write capital Z is equal to log z, because our function is in the form of small log z. So we will write here small log z, right? Now there is another example here. Solve here two or three more questions here. So solve this one, answer is here. So four questions here, so you can solve these questions, and solution is also here, so you can tally with your answer, right? Now next method is Charpit method. This is very important method. So this method is for solving partial differential equation with two independent variables. This method is for non-linear partial differential equation, right? So let the general partial differential equation be. So our general partial differential equation is f of xyz pq is equal to 0. This is our general partial differential equation form. Now Charpit equation is dx upon minus del f upon del p, dy upon minus del f upon del q, dz upon minus p del f upon del p minus q del f upon del q, dp upon del f upon del x plus pf del f upon del z is equal to this one. So guys, you have to remember this formula because this is the Charpit method equation. Now next target is find p and q from here, as we did in Lagrange, that taking first and second term to find the solution. So here we will choose that partial fractions in which including p and q. That means you will find p and q from the fractions and write the value of p or whatever you are getting first one. Then you can find another variable q, then you will write the value of p and q in dz is equal to p dx plus q dy, and that integral will be your final solution. When you will integrating on both sides, then that is will be your final solution. Now there is a question here, solve px plus qy is equal to pq. So you can write solve this equation if you are getting any type of type 1, type 2, type 3, type 4. But if you not getting any method in your mind, then you can apply Charpit method. right? So solution, and in your question method will be mentioned here that solve this equation by Charpit method if it is your 15 marks question or 7.5 marks question, right? If it is not mentioned, then you will also solve this equation by the Charpit method, right? Now f of x y z p q is equal to 0. So your given equation is in the form of x y z p and q. So this will be your function. So f of x y z p q is equal to 0. It means you will find from this equation by del f upon del x, del f upon del y, del f upon del z, del f upon del p, del f upon del q. So all you have are getting here, that you can see that you are getting each and every partial derivatives. Now Charpit equation is this one, so you will write all the values in the Charpit equation. So dx upon this one, dy upon this one, dz upon this one is equal to dp upon p and dq upon q. So which integral is very easy to containing p and q here, which one is containing p and q? So you can see here that dp upon p and dq upon p, because we need p and q only. So first we will see which one is containing p and q. So that two fractions are containing in p and q here. So we will choose these two integral. So dp upon p is equal to dq upon q. So just on integrating on both sides, so log p is equal to log q plus log a, then p is equal to aq. Now you are having p is equal to aq. So what will be your next step? You can write p, the value of p in our given question. Then from there you can get the value of q. So when you will put p is equal to aq, then px plus qy is equal to pq. So okay, so you can see here that aqx plus qy is equal to aq square. That means q is equal to, you are getting ax plus y upon a, right? So you have q is equal to, you have p is equal to, so p and q, right? So put the value of p and q in. Dz is equal to p dx plus q dy. So dz is equal to ax plus y into dx plus y plus ax upon a dy. Just integrating on both sides, so then you will get your final answer. X dy, x dy and y dx both are both term. You can see that this is the differentiation of x y. When you will apply u into v rule, then x dy plus y dx. So you can write it integration d of x y. So this is your final answer. There is another example here. Solve this equation. So you will apply the same rule here, but first you will see that this which one is very easy integral, and that integral is involving p and q. So this integral you can see here involving p and q. So just taking, so p dp is equal to minus q dq. So p square plus q square is equal to a square. So you can write the value of p square in plus q square is equal to a square in your given equation. Then you can get the value of q. After q, then you can find the value of p, and will what our next step, you will put p and q in our given equation. So dz is equal to this one. Now for the integration, for the solution of the partial differential equation, so you will do integration. So for the integration, you have to make your own self, which variable is coming with one, which variable is coming with another one. So you just have to merge your variables with each one another. So you can see here that z square minus a square y square, that means z minus y, that means z and y both are coming together. So z dz minus a square y dy is equal to this one. Now you can divide this one, because there is a function of x here, there is no need to write z and y variable here. After division, you can see that z square differentiation z dz, y square differentiation y dy. So you will consider that variable is equal to t. So 2z dz minus a square 2y dy is equal to dt. So you can write this one as this one. Now after integration, so after solution, then you will get your final answer. So there are 4 questions more here. So you can solve these questions, tell your answer with your answer. If you guys have any doubt in our first unit, because I have completed your first unit from my side, then if you have any doubt, then you can ask me You are free, all of you are free to ask me any doubt, anything, right? Thank you.